With another episode. Please don't forget to subscribe, comment, like, and share. Please, this is Elias sinkala, aka Professor. Please don't forget to do things as wise, and also don't forget to pin the notification button there because I've been missing a lot. Some videos, some people are complaining to say we are not seeing the videos, so please don't forget to pin the notification button there. Thank you. So let's start to rationalize this or such. So for me, I can say I'll just give one equation because it is as simple as it is. So please, some of you are saying to say, what is rationalization? Rationalization, don't about for me, the simplest definition that I can give, I can say it's a combination of addition, multiplication, all those rules of addition and multiplication, and also subtraction and division that make up of what you call rationalization of what sites. So here goes a quite interesting episode to finalize what rationalization. Let me say the solving of rationalization. Like what I've told you, please. In division, we are trying to make sure that the denominator is not under the root, but supposed to be pure, independent, not dependent. So quite interesting if we can try to recognize those rules and also try to remarry the work that we've been doing. So what's going to happen is this. We're going to multiply with a what? In fact, we're going to do this. We're going to make sure that the denominator being, like what you did in division, or let me say in division of sides, we're going to make sure that you multiply times 1. When I say times 1, which means the denominator divided by its denominator, of which is supposed to be in conjugate form, having same factors, having same number, and different what operating signs. So in this case, we've got minus. So in that case, we're going to have what? Addition. So what I mean is this: we're going to say multiply with the root of 5. Note that this is minus, so we're going to have plus 1 divided by the root of 5 plus 1. Here we go. These are what you call conjugate. So I'm going to create another, let me say another episode for conjugate. Let me say multiplication of conjugate another side so that you create a broad, quite interesting understanding. Okay. So here we go. So I've just created the multiply everything here, the equation with the conjugate of the denominator. So what's going to happen here is this. It will be 2 the root of 5 multiplying with 2 the root of 5 plus 1. If you see very much properly, divide by 2 the root of 5 minus 1, then 2 the root of 5 plus 1. So what's going to happen here is this, I say, so which means this 2 is multiplying with everything that is inside, and also this is multiplying with everything that is inside. So for instance, what I'm trying to say is this 2 is multiplying with 2 the root of 5 plus 1. Then, what sign is this? It is plus the root of 5. It's multiplying with 2 the root of 5 plus 1. Please, what is inside should multiply with what is outside. What is inside? What is outside should multiply with what is outside. Now, allow me to get this aside. Are you seeing this root or this denominator? You want to say this denominator sum applies are different of 2 squares? What I mean is this. This sum applies with a plus b, having the general equation a minus b, which is, what is a times a? It is a squared. What is a times negative b? It is negative ab. What is b times positive b times a? It is ab. What is b times negative b? It is negative b squared. Then we say a squared. What is negative ab plus ab? Go and that is 0. We're going to remain with what? B squared. So this same applies with this, of which our 2 the root of 5 it is a. Then regardless of the sign that is there, no problem. Or regardless, let me say the positioning of sign, no problem. Our 1 that is our b. The root of, let me say 2 the root of 5 that is our a. 1 that is our b. So it's one and the same. So what's going to happen? Allow me just to get or to use what is being provided there, or applying that general equation of difference of two squares. So what's going to happen? I say the root of 5, isn't it? Great. The root of 5, put it in brackets. Then this is a square, so I put a square outside. Then open again. I'm having a 1 here. So what's going to happen? This is, they say it is, let me say subtraction. Regardless of the sign that you are given out, as long as it is a conjugate, is appeared in terms of conjugate. So what's going to happen? The operating sign there, it is minus. This is 1, this is 1, so I put 1 here. This is 2, or this is the root. Let me say the squared, so here I put a what? A squared. Excuse me. So what's going to happen here is this. Let's go. What is outside should multiply with what is outside. What is inside should multiply with what is inside. If there is no what is inside, please multiply what is outside with what is outside, then leave what is inside. 2 times 2, it is 4, the root of 5. What is 2 times 1? It is 2. Plus. What is the root of 5? Yes, multiplies, it is 1, isn't it? What is 1 times 2? It is 2. What is the root of 5 times the root of 5? That is what? 25. Try to remember what I've been doing. Right? What is the root of 5 times 1? Sum applies 1 times 1 here. It is 1, isn't it? What is the root of 5? So of which the root of 5 times everything there is the what? The root of 5, or getting just the root of 5, isn't it? So here we go. Here same applies. These 2, or let me say this square is affecting everything that is inside there. So what's going to happen here, I'm going to say, same applies, there is the square root of 1 there. So we say, having applied power to parallel rule, or let me say, working in conjunction with the indices. What is 2 times 1 there? It is 2. Then here I'm going to have the root of what? 5. Like what I said, 2 is affecting everything here. It's affecting the root of 5, is affecting the 2 here. Minus, what is 1 to the power 2? It is 1 itself. Isn't it? So see what's going to happen here is this. So having us doing that kind of things, so see, so for the root of 5 plus 2 plus 2 times, what is the root of 25? It is 5 plus 1, the root of what? 5. What is the root of 4? Or let me say the square root of 2. I mean 2 squared. What is 2 squared? That is 4. So this squared goes with the root, so of which are going to remain with what? 5 here. Simply means when there is parenthesis here, simply means there is what? There is multiplication, isn't it? Minus 1. So we say 4 the root of 5 plus 2 plus, what is 2 times 5? It is 10 plus 1 the root of 5. So divide by 4 times 5, that is 20 minus 1 is equal to, like what I said, make sure that the denominator is not having a root. For the root of 5 plus, what is 2 plus 10? It is 12. Some of you say, why are you not adding 1 here? I'm not going to add 1 because 1 is where? Is on the side of the root of 5. Plus 1 here, the root of what? 5, divided by 20 minus 1, that is 19. Then what's going to happen? Correct the like terms, they are going to say 12 plus 4 the root of 5 plus 1 the root of 5 divided by 19, of which this same applies. Say therefore, which is the final answer, 12 plus, like what I said now, applying the addition rule here, let me say addition of such, the numbers that are under the root, if they are equal, if they are same, then you can add or subtract. So in this case, we are adding. What is 4 plus 1? It is 5 the root of 5 divided by what? 19. So this is the final answer of rationalization. Thank you very much. Don't forget to subscribe, comment, like, and share. This was quite interesting episode. Let me try to collect for you the conjugate guess, or let me say the conjugate of SURDS, multiplication, or let me say multiplying of conjugate SURDS, so that you try to give, or let me say to bring in a broad of understanding analysis. Thank you very much. See you in the next episode.